Yeah, now it's my part to tell you something interesting. And today we're going to talk about AI agents. Because AI is awesome, and especially generative AI is awesome. I hope we all agree. And of course, even code that we're going to look today also was pipe coded. A lot of stuff was generated, actually. Yeah, so why AI agents? So AI agents probably one of the main buzzwords, at least for beginning of this year. It's literally everywhere, and it sounds really cool that like AI is very intelligent indeed. But yeah, let's go deeper and see what exactly, what concepts exactly like are used there, and how we can like build our own AI agents. And we will start from building one from complete scratch without any frameworks to understand better how it works. So yeah, who am I? Yeah, I'm Nikita Zavadin. I'm platform engineer at Wolt. So I work also with DoorDash on building some cool future that we can yet share. And also, yeah, I'm Competence Lead of AI coding. So my work also drive AI codings and yeah, do everything to help engineers to be happy with AI and also to build a platform for AI development if needed. So yeah, and yeah, one of also part of the jobs to tell some cool stuff like this. So yeah, let's start. And let's start with just answering what is exactly agents and why we call AI agents agents. So it comes from philosophy, of course. So it's like Wikipedia says that it's capacity of an actor to act in given environment. And act here, it's not about just doing actions. It's about making decisions and think about the decision, like what should I do exactly? And of course, it's about giving context. And if we're talking about AI, to also like kind of simplify, agency means autonomy in deciding next steps. So it's AI that can also think, decide, and act, not just question answer, as usually it is with LLM models. So goal to make AI think about stuff that was asked by user, do some actions, and decide what to do later. So how to make it happen? So because yeah, it seems like really complicated tasks. But yeah, just to simplify what we have right now, AI agents, basically, like very simplifying, it's advanced prompt engineering. And one of the way to make it happen is like React framework. So it stands for reasoning plus action. So we need to build our way of working with LLM model and just build our prompt that way. So AI could think, yeah, like decide next steps, and then, yeah, if necessary, do it again. And React is about this. So React, first, AI needs to understand what we ask from it, then do some action, observe result of this action, and if it's not exactly what we asked, do this again. So it's whole loop. And yeah, just to give you some example what exactly I'm talking about. So yeah, just simple agent with like coding, probably that's something that we all can understand with AI coding. So when we ask AI agent something, so yeah, we send the query, and then AI should understand what exactly we're asking. So it can ask questions. So it's first step, like a reason. It can clarify questions until like it's clear to AI what it needs to do. So just always ask, you answer, and if it thinks that it's enough to do its task, then yeah, it should start like exploring environment, yeah, like search files, read files, and overall yeah, start writing code. And here one more loop. So here you can see unit tests pass loop. So yeah, it should write code, then yeah, it's like act again, and then it's like observe step to run tests, run linters, and see if everything like green, then like task succeeded. If something is wrong, like do this again. So write code, fix issues, and run all checks again. And yeah, it sounds really, really cool. So, and it seems like AI indeed intelligent. So question, do we lose already our agency? And in some way, yes. So AI already takes agency in making some decision, because yeah, like we're also agents basically. We make our decisions every day, and AI can help us with some tasks. So in some way, yeah, we're losing our agency, but at the same time, it's not exactly correct, because we're losing at this moment our doing power agency. So AI helps us with some with work, but at the same time, decisions still on us, and it's our responsibility to lead AI to do these things. So, and probably we won't lose our decision power agency unless we choose to give that up too. So, yeah, okay, we probably finished with some basic theory. So shall we start writing code and do some live demo? So now I'm gonna switch to cursor. Okay. Now, yeah, you can see my screen. So yeah, let's start with some baseline. So what problem usually we have with like LLM models? So yeah, here we're gonna send like 3 simple queries. So yeah, what's response time for Wolt.com? What version of Golang is installed on my laptop? And weather in Helsinki today. So yeah, nothing here very specific. So it's just simple query to ChatGPT. And of course, some of you can already understand that it won't be able to provide us questions. But still, let's run it and see that indeed we have some problems in this implementation. So yeah, with response time for Wolt.com again, it doesn't have real-time access to the data. Version of Golang, it's going to answer something similar. It doesn't have access to my machine. And weather, also problems that it doesn't have real-time data. So this is the problem. LLM model doesn't have like enough context, and just currently it lives in very isolated environment that like on old knowledge that it has. And this is the challenge that we need to solve. Yeah, like how to provide more context and right tools to interact with environment. In this case, yeah, like my laptop and maybe also web search. So yeah, let's take a look at basic agent. So still the same questions, but here instead of just simple query, we have interesting function run agent loop. So let's take a look here. So how it starts? Still we have our OpenAI client, but how we start that we define 2 messages. One is system prompt, and second is user query. So that's what we ask, like, what is response time for Wolt.com? And if we take a look at the system prompt, it's exactly this React framework that I was talking about before. So it describes that, yeah, you're in a loop, you need to think, act, pause, and observe. And here we provide how exactly it should work. But also, as I told, AI, like LLM didn't have like context and didn't have any environment to interact with. But here we provide actions also. Ping to ping some websites, bash to execute any bash commands, web search to do Google search and find links, and scrap to scrap pages from the web, get content. So here are some examples just from for better prompting. And here our actually Golang code, and this code gonna be executed by AI. So here you can see that you can write literally any code, and it's gonna be connected with LLM. So it's like our connection between something that lives somewhere in the cloud and our code that can execute literally anything. You can put anything. So it doesn't need any serialization. So yeah, we all have ping, that pings website. We have bash. Never do this at home, of course. So it's only for demo purpose. You probably don't want to do this in production. Web search and scrap. So it just returns HTML or anything else. So let's see what happens next. So we have this loop, and it has limit with max iterations. Why? Because like AI unpredictable, and it sometimes can have this infinite loop issue. So you would like to limit like max iterations. And that's why it's a good idea to set some max iter. And in this loop, we always send query. So how it starts, I just remind, it's system prompt plus user query. So what's response time for Wolt.com? So we get response, then we parse it, find action, and action input. And here now we have this simple switch. So if it set to us execute ping command, we execute like ping function and pass their input. And yeah, then we collect results from it and append to our list of messages. So now it has observation. And then we start it again. But now it has more context So we want to query again with observation, and it's going to get result of our like action. So and eventually it should find answers to stuff that we asked. So let's see if it indeed works. So first question, response time for Wolt.com, and here you can see how it works. So it has a toad. To determine response time for Wolt.com, I will attempt to ping the website, and it indeed told us to do action ping with right arguments, and it got observation. So yeah, we got answer that response time is less than 1 second, no more actions, agent is done. Cool. Go version is also should be simple enough, right? Same. It also understood that it needs to run bash command. It executed, got version, and here's answer. That yeah, it's also complete. Everything so far so good. But now, the most interesting thing. So like we asking, what is the weather in Helsinki today? But we don't have tool exactly to get weather. So like it's two-stage now. It's not just selecting right tool. It's about understanding that, okay, first I need to do web search to get websites that provide weather. And then I need to scrap some website and from this HTML get all data that I need. So now it's like through agentic. So it needs to understand what to do without our hints. And let's see how it works. Okay. So to find weather in Helsinki, yeah, I should look for weather information from AccuWeather. So yeah, it performed web search, Helsinki weather, got some links from for AccuWeather, and now it understood that, yeah, it needs to scrap this link. So it took one link that looks the most related, and it executed scrap command. So yeah, here's huge HTML. Now let's see. So yeah, seems about right. So current weather in Helsinki, 60 degrees, local time is right. So yeah, it works. And this is like basics of agents. That's how it works. So you just write prompt and right set of tools. But yeah, here you probably notice that yeah, code kind of looks, let's say, not perfect. And of course there is some pattern. So it's loop, it's prompt, and switch. So you probably would ask, like, is there a better way to write AI agents? And of course there are some different frameworks. So let's take a look how we can rewrite the same code, but on some frameworks. And for this purpose, actually, I skipped slides. So yeah, just to give you a short overview, what is used also inside of this framework. So some time ago, OpenAI added this tools functionality to their API, and it's like help in building AI agents a lot. So you still like define your function somewhere in the code, but when you make requests to LLM model, you like pass whole description, like in JSON format of your function. So name, description, so it could know what it does, and description of your parameters. So all arguments that your function accepts should be described in this JSON schema object. And yeah, it's going to be used by ChatGPT to trigger right functions and interact with your environment. So yeah, and these frameworks actually like embed this thing inside, but provide to us some very easy like Golang interface. So it's still the same. We have some tools. And yeah, what we are using here, we use LangChain. It's like Golang, an official Golang implementation of LangChain library that is primarily for Python and JavaScript. So that's why I would recommend to be careful, since it's like unofficial. So what we have here, let's take a look. So yeah, we define our list of tools. Still the same tools, ping, bash, web search, scrap, but now it looks much more extendable, right? So if we need to add new tool, we don't need to change our prompt. We just need to append to this list. Cool, and now let's take a look how our tools look like. So it just needs to implement the simple interface, like it needs name, description, and of course, implement call method that actually performs some logic based on input. And it's the same for bash, web search, and scrap. So what happens here? We define these tools, we create our agent, and now we just run. And you might ask, like, where is this prompt that we previously like were defining? And actually, if we're gonna dive in this framework, we can find the same prompt. It's still like a React framework, so like written in different way, but basically the same. Like think, act, observe. But yeah, it also has some template. Cool. So it already like simplifies and removes some boilerplate for us. So we can just create our executor and run it. So let's run it and see if it still works the same way. So yeah, with ping with response time for Wolt.com, it's cool. So yeah, it triggered right action. Go version also the same. And the most complicated, weather in Helsinki. Okay, again, searching web, scrapping Akku weather. And now it will take some time, but yeah. And now, okay, interesting. It executes also some bash command that I did not expect. So be careful. And yeah, result, current temperature, 16 degrees. Cool, it works. But yeah, like we can write these agents, but eventually probably we're gonna face some problems, right? Nothing, AI agents is not some magical tool that can solve all your problems and be universal. So in this architecture, what problems we're gonna face? That if our agent will become like too complex, it's gonna have like too many tools, too many functions, and eventually it will make a LLM model making like poor decisions about which tool to use. Because yeah, like too many stuff, huge context, not great, it's gonna be confused. And context also the same. So if you give to one single AI agent huge task, you can try it in Cursor, and you can try to build some huge enterprise project. After some time, yeah, it's gonna start working, like very poorly. So it's like context issue that currently we're all facing and that we need to solve somehow. And last thing, it's of course modularity. So maybe you need some agents, like with specialization, like planner, researcher, math expert, because again, context. If you provide everything like in one prompt, like okay, you're a researcher, you're a math expert, eventually, yeah, like AI gonna be confused, and yet it would make sense, to somehow make it modular, and it's also like. From code perspective, also much better and much easier to debug. And now we come to multi-agents, so like apes together strong. So instead of using just one agent, like here, single agent that just calls tools, we can build multiple agents that can like talk to each other basically. So here are some patterns, network pattern where every AI agent can talk to any other AI agent. So and there could be loops, but yeah, like it's like just people talking to each other. There is also popular pattern supervisor. So like there is one manager, so and all other like AI agents that actually do work. Supervisor basically coordinates work between agents, and you can see here that supervisor has connection to agents, but agents itself doesn't have connections to each other. So like they talk only through supervisor. Yeah, like hierarchical. So like it's whole organization. You can build some teams here, like manager that has managers, and manager have these agents. So you can even try to build your own organization, like your own AI HR department, your own engineering, your own marketing, and actually there's even some research that so like researchers try to build IT organization based like on AI agents, and results, let's say, were not that great. So we are safe at this moment. AI cannot replace us completely. And yeah, like last pattern is just literally anything. So like nobody limits you what you can do with AI agents. So like you can build these graphs like in any way that you would like to. It's just like matter of your creativity and what you think is the best. But yeah, why does it even help? So like why do we need multi-agents? So let's then just talk about what agent 1 sees when it calls agent 2. So to remind you, we have context problem. It's always the same with AI. We need to always make context smaller, and that's like where multi-agents help. So when AI agent have some problem that and it knows that AI agent 2 can help with it. It's gonna call AI agent 2. It can be the same tool. And AI agent 2 gonna hide all its own like thought process and everything. So it just calls, and then agent 2 make tool calls, thinks, process data, and just gives final response. So instead of having in context this whole thinking process, it gives on the final response, and agent one, gonna have like smaller context to work with. So, and the more like agents you have, so like you can work on very complex tasks if you like make it modular and performed by separate agents. So now let's take a look how it works. So here we have multi-agent snippet. So now we use actually different frameworks. Why again different? So yeah, during my research, I found that like different frameworks for Golang, like better in one things, but horrible in another. So, and with Swarm Go, it's also the same. And it shows that like AI environment for Golang is not yet great. So Python has much better tools for AI stuff. So let's see how this workflow works. So now we have like, we're gonna implement the supervisor pattern. So there's supervisor that coordinates job between agents. And what we're gonna do, so like maybe you use this research tool by ChatGPT when you ask to research some topic. It does like huge research, like searches in web, process all the data that it scraps, and then make research. And that's like what we're gonna do. We're gonna do the small agent that can also scrap web, and then write some report based on scrap data. And for this, yeah, we have supervisor that can clarify requirements that we, like if we ask some query, and then we can expect that supervisor gonna ask some questions, what exactly we want to do. We have writer agent, and it has this writer functions. It can write files, so it could write some like file with report after like whole research is done. So, and it should write like edit our report and then write to file. So, and here we have our function to manage files and basically have access to my file system on my laptop. And scrapper function. So, and here the same, it's search web and scrap URL. So yeah, it's job of this agent, yeah, to search web based on like on topic that was asked, and yeah, provide all the necessary information. So we split our one huge job on research to move like 2 different parts, and actually 3 different parts, because supervisor also collects some important context from us. So how does it look like? And here's our agent. So we give some instruction that yeah, you're like manager, you have your own agents, your like workers. You can ask them to do their work, and we provide functions, and the same with writer, the same with scrapper. And now we built a team. So very interesting concept. So yeah, we build a team of agents, and we set a team leader, our supervisor agent. So like a supervisor leads everything, and it's gonna be like entry point for user. So like when we ask something, first who gonna like get message from user is supervisor. And now we just build this graph. So we connect supervisor agent to writer to scraper, but we don't connect writer and scraper to each other. So like all communication only through supervisor. And yeah, we just give some user prompt that I just want a report. So on something that's happening in the world, but we don't specify what exactly. So what we expect that AI gonna ask us, what exactly do you want? Because like this topic is too broad. And then we just execute it. So yeah, like very simple code actually, but that conceptually like very complicated. So let's run it, actually not like this. Yeah. Okay, and yeah, now it asks us like what exactly do you need? And you can see that there is nowhere in the code like any input like that tells ask user about topic. So like AI understood it, it needs to ask human because it's lacking context. So let's write IT news today, and let's better use routers. Okay, and now it triggered Scraper, you can see here. So Scraper triggered searching web for our prompt. Then, okay, it skipped probably whole scraping, so let's try again. So it can be unpredictable sometimes. IT news today, routers. Again, it goes to scrapping, it's searching web, and what we expected, it's gonna go back to supervisor, and supervisor gonna tell scraper to scrap this URL. So, yeah, it's scrapping definitely not routers. So I think DuckDuckGo doesn't work that well. But yeah, let's see. It's actually something in German. So now I'm very curious what output we're gonna get from German news. Yeah, and it's processing, and I'm not even sure that you can scrap this website. Okay. Now Scraper returned this data to supervisor, and supervisor should send this data to writer, and writer should create a file for us with summary of everything that was scrapped from the web. Okay. And now, yeah, we got to writer processing some message. Let's see what's gonna happen. We should see here that it's creating file and writes to it summary of all news that it got. Yeah, takes too much time, actually. Okay, cool. It created file, so let's see what's here. Source, routers, technology news. I'm not sure it's routers. But indeed, yeah, something about Amazon, Telegram, Elon Musk partnership. So it seems like something that happened today. And let's see what's here. Yeah, it even generated some conclusion, and that this report was compiled today. So actually pretty cool. I don't know what exactly it's scrapped, but it seems like something that is true. Cool. Yeah, well, now we know how to build AI agents. But actually, do we want to build? Do we want even to build agents? Probably, in your company, you don't need agents. At least if you don't know how to use them, you don't need them. But we have already some cool agents. For example, something that we have in Cursor, it's also agent. But can we make Cursor agent even more powerful? Because you already saw that these tools, it's some functions. Can we extend these functions? Can we provide something to help model with context, to integrate, for example, with our corporate data? Because we can have our promo documentation. We all have our internal libraries that have some documentation somewhere. Can we help somehow, Cursor agent with it? And yeah, folks from Anthropic, yeah, they developed this MCP protocol. It stands for Model Context Protocol. So basically, it's protocol for client and server, how they communicate to each other. And Cursor implements some part of this protocol. And so we can connect additional tools, which are called MCP servers, to our IDE to provide it more context. And these servers can do anything. They can interact with some environment. They can go to some database to provide you additional information. They can scrap your corporate internal portal. So anything. So it's just limited to your imagination what you can do there. And LLM model gonna work with information that you provide from MCP server. So let's see how it works. Here's MCP. Okay. Let's see. So here we use Markfield Labs library that implements this protocol. And I also would not recommend using this because soon we're going to get official implementation from Anthropic folks, actually from Go team, but under Model Context Protocol GitHub repository. They already have like really large RFC. You can read if you are curious. So yeah, if you're thinking about giving some production tools to your engineers, I would wait a little bit until we get official support. So, but yeah, meanwhile, we need some MCP in Go. Let's see how we can build it right now. So we create first our MCP server, and still again, we create tools. And we use only one tool, get documentation. Here we add it. And yeah, we give a whole specification of it that, yeah, it needs package argument, it's required, and of course, description for everything. So AI could know what exactly to do with it. And yeah, we add our tool, and here's our function. Like, yeah, we just get package name and return the smoke response. So nothing specific. And now let's build it. So yeah, we compiled a binary that we can use in Cursor. So here, Cursor settings, MCP, and yeah, we can just enable it because I already added, but yeah, there's nothing complicated. You just need to provide this command to your binary and it's gonna work. So now it already got this tool get documentation. So specification works. Now let's actually trigger this tool. So let's open some code and in wrong button, let's ask something. Can you provide documentation for this package? Use MCP, it just to make it more predictable. And now interesting part that we need to say, do not think, just give me raw out. Why? Because like ultimate goal of agent, of course, it's to think, right? That we already found it earlier. So it's like one of the basic prompts. And here you can see that it's just some mock documentation. And AI, of course, will understand that no, it's not related. It's something very generic. So I should not use it to like give my answer to user. So it's gonna parse code and it will try to make its own conclusions. So that's why we just say do not think. And now let's see. Cool. Now it understood that it needs to call our get documentation MCP tool with like a package. Yeah, and here is our documentation that we like built here. And yeah, you can build these MCP tools for anything. So yeah, for your corporate portal, as I said, you can build integration with Slack, I know with Confluence. Of course, there are already some MCP servers that you can use. You can just connect to your IDE, like GitHub MCP server. So it could like create pull request for you, create issues, create search in GitHub, find documentations or repositories. So like full integration with GitHub, and also of course there are some MCP servers for Kubernetes. If you would like to interact with your dev cluster, for example, from IDE, like using your AI agent. So you can again, your limitation here is context and your imagination. You can build very cool things with it. And that's basically it. So yeah, thanks everyone for attention. And here are a couple of QR codes. One with GitHub repository, if you would like to explore this code. And yeah, second leads to like my contacts, if you would like also to message me or just connect. So yeah, that's it. Thanks for attention. And now I'm going to be happy to answer your questions if you have any.
Let's go straight to the questions. I will try to do my best with time. Okay, we have one already.
Thank you. Thank you for the presentation. I have a question regarding agents. For what purposes you will use it in the work, except the documentation?
Well, it's like agents already like integrated with our IDEs, and engineers, it's like expectation that engineers gonna use it also like frequently enough. And our goal, not to like reinvent the wheel, but yeah, to extend this context for agent. And we already have some cool thing called Glean, so it indexes our whole like Confluence, Slack, GitHub, and if engineer, like get stuck with something, you can just ask like, okay, I need to find documentation about this, or I just need to find some Slack conversation where it was discussed previously. And yeah, it works pretty well. So, and another things, yeah, again, as I said, some Kubernetes integrations. Also, we have our internal frameworks, so we also would like to extend whole understanding of our frameworks with also MCPs. Currently, it supports only tools in Cursor, but in future there will also be like things like called prompts to also help agent work better. So like it's also a matter of time when Cursor gonna add full functionality of MCPs. But yeah, agents, like it's not even about just writing code. Agents can help, with also probably support folks to make some decisions. Yeah, like if we get some ticket, probably it can, do some interactions, think what it can do, can it refund? Of course, we cannot trust it, so it should be reviewed. But yeah, it's just some automation, and so the main thing that it can think, it's not just some workflow. And there is confusion between workflows and AI agents. It's both agentic systems, but AI agents can also like make decisions on their own, and workflow just follows some described workflow. And yeah, actually a lot of use cases, and we experiment here and there. So, and probably we're gonna share if we're gonna have some success stories with AI agents.
Okay, thank you.
Thank you for your presentation. It was really cool. I have perhaps a simple question. Currently, all those AI models are really fast evolving, and almost every month we have a new, if I'm not mistaken, new version of Claude just come out. If I understood correctly, all those agent frameworks are based on prompt engineering and correct prompts. What if the underlying model is updated and changed? Does it mean that we need to update all of our prompts and rewrite our systems entirely?
Yeah, but of course, like these prompts, AI agents encapsulate the choice of this LLM model. So if you like pay some company or AI agent, they should like already take care of it and think what AI models work better. But yeah, of course, it can think that some models can work worse or better with the same prompts. So maybe it can happen. And yeah, also the whole point of this MCPs to make this agent agnostic interface. So you can connect this MCP server to literally any agent that implements MCP client protocol. So and that's why it's like that widely supported across like very different organizations like GitHub.
Yeah, thank you.
Thanks for the presentation. You showed this different kind of interacting models of multiple agents. So do you have any rough idea, like which one is the best, which one is mostly used, like what are the trade-offs, one or something like this?
Yeah, it's indeed a good question, and honest answer that no, I don't have like any research that I know that explores what is better for most of cases. Of course, it depends on your task. For example, what we done are in our exercise. Supervisor was a good choice because it just coordinates everything and there is less unpredictable things. But if you maybe do some maybe coding, it would be nice so that engineers could talk to each other, like virtual engineers. I mean, like virtual front-end engineer could connect the virtual backend engineer. Like, okay, I need backend for this. I know this endpoint. Write it for me. So that's when network can help. So it's also one of the engineering, to understand how would humans solve some task, and probably AI also gonna work good in these conditions.
And like, what about like if there is a kind of misleading response from one of the agents, like wouldn't it like cascade?
Yeah,
Like-
indeed, it's also one of the things, and that's why when we can come to again supervisor. So there are also like popular pattern to have some reviewer, so like a separate agent like reviewer that also, like one agent performs work, returns it to supervisor, and then reviewer like evaluates if it's like good answer or it's something misleading completely, and then gives feedback to like previous agent that okay, you need to do your work again. I don't like what you've done. So it's also handled by this reviewer pattern.
Okay, it also kind of depends on the case, like what you want to do, I guess.
Yeah.
Thanks.
You talk too much about cursor. Is it okay to use it in work with your code base?
Yeah, especially like in our like mono repo, where it has like very good like context about how we build things, and there it works like perfectly if you like product engineer. So like you have some task and you have frameworks around it. So all building blocks are ready for you. But for example, when I'm working on developing this framework, and sometimes we have some magic with reflection and AST analysis.
No. I mean you just give your code like or not not LLM in your like AWS Bedrock or something like Google Vertex AI, but you just send your code into Cursor via Cursor.
Send my code like via Cursor where?
I mean, like in Cursor, you cannot add your LLM proxy.
Probably no, but there's like selection of different LLMs, so I would assume that at some future.
But this is not yours. Like this is proxy on Cursor side.
Okay, so we are talking about this privacy considerations. Yes. Yeah, like
of course.
Cursor.
Because with Cursor or Windsurf, it is kind of way where actually invoice you for using where like API.
Yeah, I got your question. So yeah, of course we use like enterprise license, and every enterprise license like it's like part of agreement that it has like very high like security standards. Of course, it's like a risk that our cloud provider of LLM models can store some data, but like it's part probably of agreement that they should not store our data for like long time. So like of course, if you pay for some like pro license or like not enterprise, your probably some parts of your code can be leaked. And but yeah, again, we always pay for security like enterprise security standards to minimize these risks.
Out of curiosity, how big is the like how much are these AI agents used today, like in corporations?
It depends what AI agents. Like coding AI agents probably like widely used.
Like say, what are the real use cases for this?
Yeah. Well, there are different. Like there are also like AI agents like support workflows. Probably can be useful. For example, if you have some like let's say channel that or command team, that process a lot of requests from people, and in this case, like agents with some simple workflows that can answer, sometimes create a ticket, can help significantly. So, but we're not on this stage. We have like our dev bot that probably has some agentic stuff, but it's not probably that agent yet. So it just can answer to some most frequent questions. It has like whole, like knowledge database about stuff that related to some channel. And if person asks something, it will first look all data, find the most related stuff, and there's like huge bunch of documents, like 300 pages of different documentation. I just recently took a look how like some bot works for one of our channels. So like a lot of documentation and still cannot find right answer and even provide some confidence. So and probably it's gonna evolve in future. So just to make support of people easier. And of course, coding also a big part. A lot of people use Codex. A lot of people use Cursor. I know I use agent in my Cursor ID almost every day. I will talk about something. I will ask like to summarize something. Like write some comment or do some routine work for me. So I know I would say that I already use agents like every day because like yeah, I write code every day.
Okay, thank you.
Thank you for presentation. As I got it so far, you are currently most used agentic AI in the corporation level, but I haven't heard anything about how to use it, for example, in the application level with the users. Do you have any, for example, plan to use in this generative AI with the users too, or if you want to use it, which direction do you want to go?
Yeah, good question. And of course, our product's also researching this, and we have even some AI hackathons inside of Wolt. But I'm not probably nothing yet deployed to production. But yeah, we are trying to find how to use AI better for product. Yeah, also like consumer facing. But yeah, even if we integrated like some backend, like support that it's hidden from user, it can still like help with user experience because like support can be faster and better. So probably I'm not ready to like give exact answer of what we already implemented with agentic systems involved in production, but I can definitely say that it's gonna be one of the point that we're gonna research in like next years how to collaborate with AI better to like maybe find something that wasn't yet solved by other companies. And yeah, if there's gonna be something cool, we definitely will share.
Thank you for your nice presentation. Back to the multi-agents topic. As we know, the agents can perform non-deterministically. So do you know a pattern except the supervisor to keep this whole communication deterministic? Is there a way, or it can just turn into a mess? Or what's the pattern for error handling or failure management? Should we always include humans, for example?
Well, but maybe not exactly answering about your multi-agents things, but yeah, we had recently some huge refactoring of our code base. So like, it's like very like routine work, but still it's complicated for AI to do everything. So what we have done there, how we like made agent work better. It's like very specific steps it needs to do. So like it was like prompt engineering. Yeah, we have written some YAML with workflow. It doesn't have exact like syntax. That's something that really exists. So it was just description of workflow, and we provided like instructions to AI that okay, you like this system, you need to work with some provided workflow file, and yeah, you can like run commands that you need to like for validation that everything works. But yeah, follow this workflow file to perform your job, and yeah, it worked much better than you would just ask like agent, okay, refactor my code like using cursor rules, for example. So like sometimes you need to combine also workflows that describes exactly how to do something step by step to be more deterministic. And also here like it's important to choose a right model for it. So yeah, if we open our even cursor here, so yeah, we can see that it has like different models, and cursor documentation also provides some like decision tree what model you need to use. For example, if you need more creative AI, you need to choose Cloudy 3.7. So in thinking mode, so that's if you have some large task that needs creativity, yeah, choose it. But yeah, if you have some deterministic steps that you need to execute, but it's better to use Cloudy 3.5 because yeah, it's less creative. So it's mostly about following like if you would like to control it, you would choose like this model. So yeah, it's also about choosing right models for right tasks.
Thank you.
Yeah, thank you very much for the presentation. Just wanted to ask about Go. Like, what is your experience compared to Python, or why did you go with Go? Just for the meetup, or what do you use actually in production?
Oh, sorry, I'm trying to find you. Okay, can you repeat your question, please?
Yes, just want to ask about Go. Like, why would you? How is your experience? You mentioned it's not such good as Python, maybe so far. Why would you go with Go? Do you actually go with Go right now compared to and so on?
Yeah, maybe for we are building monorepo, and main languages are gonna be one of the main languages gonna be like Golang, and yeah, it makes sense to also add some, for example, MCP platform like that based on Golang. So like because the whole code based on Golang, you have Golang engineers. For them, it's just easier to write Go code, and it's also cheap because like there are different distribution models for MCP, and one of them, something that runs on your machine. And when you have like Golang binary that's very small, like it's much better than building huge Docker image, especially with Python, the case. It's one thing, but Python's still like probably one of the most advanced languages with AI tooling. It has like support also from OpenAI. It has like Swarm framework from OpenAI to build agents and multi-agents, and it's like really great. So for building agents, probably still choice would be Python. But Golang, first of all, because we have like some Golang Meetup, so that's why I had to prepare Golang code. And also it can be the case if your agent needs to do some Golang specific fork. For example, I don't know, you need to parse like AST of your code to provide some analysis. Maybe you would like to build MCP server that should visualize your code. I don't know, like for this use case, but maybe and then for this you need to parse Golang code and would use AST. And maybe you have some like compute like heavy work, like maybe calculate embeddings. But in Golang, that's when you can also like choose Golang for it. But you still can develop different servers. Like some servers can be used Golang, some Python, so you are not limited here.
More questions? Okay, seems like it's all covered.